In this first exercise, I'd like to start with Analyzer CAD library items. We would like to draw a simple utility item. The reason why we use library items, they have already all the part properties attached to it, and it makes it a bit more simpler. So the first thing what I like to do is I want to make sure that I have the pick style set to on. That means all the library items, they get grouped up in groups, so they're a bit easier to manipulate if the pick style is on. So what I also normally do is I draw up quickly the room situation, so we know where to place all those items. So that's just simple, basically simply a few lines. Let's say 800 deep. The whole thing is 1600 long. And just a return wall again at 800. In this case we have a 600 bench top. So I'd simply offset the back wall line there. I may put that in a different layer, so there's a bit of a color difference. Let's say put it into the work layer here. This is the benchtop line here. The cabinets are 20 mm behind. There's a 20 mm benchtop overhang. And it's probably a good idea to put the line for the plinth as well. That one is 50 mm further back. Another good thing is putting in the side scribes. In our instance, we want to do them 20 mm as well. So I can match the properties here. And possibly trim them a little bit. So that's basically all we need. Now we can start with Analyzer CAD. Go to 2D tools. Here it gives us different object types. So they're grouped up in base cabinets, finger pull cabinets, extras, plinth, tall and wall cabinets. So we start off with our base cabinets. We want to start with a drawer unit on the left hand side. In this case a variable ones. We place it in the corner here, and since it's a variable drawer unit, it gives us the choice of our first 3 drawer heights. The fourth one is automatic depending on your cabinet height. So let's say we want to do that second drawer at 200 and the third at 220. So here we specified the heights of those. Now we can vary the depth of the cupboard, but in our instance it's exactly already on a line here where our cupboard's supposed to be. Now we want to put another cabinet in there. All we do is we go into 2D tools again. Base cabinet's already selected, and we want to add a 2-door unit on the right hand side. So these blocks here, they're dynamic blocks. They can be changed. They can be stretched. For instance, we can stretch it to that side there. They can be stretched in any case. They can be rotated around. Or if we can attach them to a different wall in a different direction. They're actually not 3D objects yet. They are just placeholders for 3D objects, so we can move them around, stretch them. We will, at a later stage, we will populate this with 3D cabinets. The next thing we want to do is put the dynamic block in for our plinth. We select plinth. Now we have different plinths here. As you can see, this one's between walls. This one's seen all around. Seen both. So we basically have our simple one between walls. So the object. Select this far corner here. Now we're going to stretch this to the right-hand wall. And we just bring it a little bit forward to our line here. So that's all we need to do, and the same thing goes for the bench top. 3D tools. Bench top is under extras. So we want to use just a simple bench top. Our bench top is way longer, so let's put that in between there. Place it on our bench top line. We probably want to have this a little bit oversized, so we can simply make it 20mm longer here, so make it 16-20. So that gives us 20mm oversize, so we can scribe it in. So that's basically all to it. The next step would be creating a 3D model of those dynamic blocks. Now, Analyzer CAD has global settings, so that's your general settings that you have in your company. So that it specifies which material you use for carcasses and what thickness you use. We generally go slightly, if you use an 18mm board, we go to 18.3. The reason for that is that there is a tolerance in a board. Quite often boards can be up to 0.3mm thicker. So we really don't want to have our cupboards to grow. So we allow for the highest possible tolerance, and that works out quite well. The same thing back. We use all our material fronts. They have an external material. The actual material for the job we will assign through Analyzer Manufacturing at a later stage. So at this stage we simply have a generic material specified. There's other things like gap generation for doors and drawer fronts. We can specify them. Drawers, they're generally 16mm. Your base, your kick materials, the bench top, and also your normal construction method for Analyzer. In this case it's screw. And you have certain basic heights. Let's say your kick height is always, let's say, 140 in this case. So that's just general global settings. They don't influence the job actually. So what actually happens to your drawing here is in the job settings. Every job is possibly slightly different, so you can change the materials according to what you need for the job, but you can always reset it to global defaults. When you press this, it'll copy the global settings, your company settings, into that job, and then you can start changing it, because you might have a job that's completely different and you want to set it back to your normal company settings again. You can save these settings, put your job number in there, you can fill this in, and you can save it as, and just open them again, and you have your settings that you had there. Your cabinets, they will be generated according to these sizes, so your base cabinets, they will go to a benchtop height of 900, basically what it does. It shows it here in the diagram. Height 1 is your kick height, height 2 is your benchtop height, your cabinet height is the difference between the two of them, minus the benchtop thickness here, what you specify there. Here you can select your construction method. In this case we want to do a screw and dowel, and we set the kick out to 100. Now we want to generate the 3D cabinets. We want to go into a slide 3D view here. So what we can do is we can generate all of them at once, or every single one. I'll show you the populate all command. All you press is this command, populate all. And out of those dynamic blocks, it'll generate the 3D cabinets according to the sizes of the blocks and the sizes we set up in the job settings. Now I want to demonstrate to you how the job settings influence the generation of the 3D cabinets. So if we go into job settings and we want to reduce the kick height to 50, just press populate all it does, it deletes the cabinets and it rebuilds everything to a 50mm kick height and adjusts the drawer. You see the bottom drawer is a bit bigger now. Since we have set our pick style to 1 and our group selection is on, so we can just show you quickly, we can easily manipulate each of those items. So we don't need to move each part, it's all grouped up. I can show you quickly how all the part properties have automatically been assigned. So that because we selected the bench top, so it's already called bench top. It has the material assigned to it as per job settings. It sets a nest prep property because we're assuming we're going to nest this part, and also it has already selected the right assembly there. In this case it's extras. Or you select the part in your cabinet. In this case it was the adjustable shelf. It gives you the material, type of etching, and in this case the assembly is the base 3 cabinet, and the construction method is screw and dowel, so that has been done automatically for you. Now we want to go a bit further and draw a hole in the bench top. So we can simply go back to our home screen here in a ribbon. I probably would turn off the group selection here because we want to work with single 3D objects. So we want to do the hole right in the center there. Draw a little construction line here. Let's say about 600 from the right hand side. And we want to do a round hole of 360mm diameter. Select the cylinder because it's a 3D item. 180 radius. And we just pull it down a little bit. So basically what it's done now, it's done a cylinder inside the bench top there. You don't really have to exactly match the thickness, it can be a little bit bigger. So what we want to do now is a 3D subtract. So we select the first item is our bench top, we press enter. Press the second object, we press enter again, and now it does the subtraction. So basically it's done a hole for us in the bench top here. Now there's only one little problem. The top rails, they're actually going through, so we can also automatically cut them out in a round shape. Now we want to make those cutouts slightly bigger than the cutout on the bench top, so that allows for tolerances in your bench top. So select cylinder again. We select quadrant. And we draw another cylinder, but this time we want to make it slightly bigger. So I'll make it 200mm radius. Now since we have two top rails, we need to do two subtractions. So we make a copy of this. Just copy it on the same spot again. So we have two cylinders on top of each other now. Now we do our subtraction. Select the back rail, press enter. Select the cylinder, press enter. So our back rail has been subtracted there. Same thing for the front rail. Now we have two cut out rails. We can delete our construction line there. Now this is basically ready to export to Analyzer Manufacturing. For that we go back to Analyzer CAD, press the Analyzer icon here, and we select all the boards. Press enter. Analyzer Manufacturing pops up now. You can enter a job number, work order number, client, exercise 01. Now here it shows you all the assemblies that Analyzer CAD has created. It shows you just the sizes of it. It hasn't got any machining assigned. So to do that, you have to press Geometry Script. And now it's assigning you all the machining, the drilling, the cutouts, where the other parts join, and the naming, as well as the etching. As you can see, materials and edges are generic as they've been assigned as per Analyzer CAD job settings. So now we can assign the proper values for it and assign materials as per job requirements. We go into job material equivalents for that, and it lists us all the materials that are used on a project here. 16mm internal, that's your drawer material. So we can select the material in the database of Analyzer Manufacturing. If we press the asterisk here, you can access those materials. You can type in any one that you like. It doesn't necessarily need to be saved into the Analyzer Manufacturing database. So we can go, we want to use 16mm wide particle board. And the edge material would be 1mm wide edges here. We can select them as well in the database. 1mm wide edge here. This one is your external material. In this case, we want to use a Formica board, grey Formica board. So that's 18mm. And we have a 1mm grey edge. The edge thickness, it depends if you use pre-milling. You don't touch the edge thickness because your edge bander will automatically take this off. If you don't do pre-milling, you have to specify the edge thickness there, and Analyzer Manufacturing will automatically make the cutting size 1mm smaller or whatever edge thickness you use. 18mm internal. I use 18mm wide particle board and 1mm wide edge here as well. Kickboard, we want to use Formica grey again, 18mm mica board. Doesn't have any edges, so you don't need to specify anything there. Your bench top, you want to use a 32mm black Formica, and the edge is a 2mm black edge. Hardware, we don't need to specify anything there, so we press OK. So it's asking us if we want to take that over. Say yes. Now once we run the geometry script, you see now our left-hand end, for instance, it's in wide particle board, 18mm, and it has a 1mm wide edge. Same thing for our top rails. Our cupboard doors, they are Formica grey, 18mm, and they have grey edges all the way around. You can have a look at our drawer cabinet. It has drilled the ends according to the bloom drawers that we have selected. The front, for instance, gives you the position. This is our 4th drawer front. It's got 4 small little pilot holes underneath the drawer bottom, so you know which drawer goes where. This is our 3rd one, for instance. And we've done all the edges, wide edges, on a 16mm board, as well as the grey edges in your drawer fronts. The plinth has been drilled. There's not enough room for dowels, so it just has drilled the normal screw holes for it. Because remember we selected screw and dowel, so it does dowel holes here and screw holes. Now we want to save this analyzer file here. Save as. I want to call it exercise 01. It saves it as a file type ANZ, that stands for Analyzer Manufacturing. So we can recall this anytime. Analyzer Manufacturing also provides you with a variety of cutting lists. You can access them here. There's a simple general cutting list that basically lists all the materials by cabinet or by assembly. You can skip through the various pages. So this is your normal base cabinet. That's the extras, that's your bench top. And it gives you a summary of edges that you use and lineal meter rate. It provides you a summary of edges that you use in lineal meters. Then there's also the consolidated cutting list. That list is grouped by material and thickness. Now I'd like you to save your ANZ file and your DWG file, your AutoCAD file, and submit it to the classroom.